Thank you very much, everybody, for coming tonight. It's been nice to see so many people. I should do a few introductions to start off with. My name is Paul Greening. I'm from the UCL Centre for Engineering Education. For those of you who don't know, it's a relatively new beast. It's a collaboration between UCL's engineering faculty and our Institute of Education. So our feeling is that between us we can bring some interesting new views onto the question of how we educate engineers in the UK, and we're looking broadly, not just in HE but across the whole spectrum. One of our activities that we chose to do is this conversation series. So tonight is our second conversation series. Our last one was a couple of months ago and looked at a very different question of apprenticeships. Tonight, though, we're looking at new models of education. We've got a couple of really good speakers who I'll introduce in just a moment. The plan is this. They'll set the scene, but we've called it a conversation series for a reason. We want audience participation, so we're not looking for 101 questions fired at these guys. We're looking for an interesting and wide-ranging discussion. We're recording tonight. We'll put the video up on our website. There's a number of people who've expressed an interest in looking at it later on. And hopefully the discussion tonight will create a bit of a buzz. I will blog about it. Maybe others of you, if you haven't managed to get your own points in during the evening, will want to respond. So hopefully we can create a bit of a buzz. The hashtag we're using is CEE buzz, if anybody wants to use Twitter. So, just before I introduce our speakers, we've been planning this event for quite a long time, actually. I think my first conversation with Karen and David was probably 5 or 6 months ago. And I think, this whole question of new models, new providers has become more and more topical, and the recent Green Paper is a really good example of that. So hopefully we can explore a lot of the themes which have been emerging recently, and just looking even at some of the stuff that's the headlines in the Times Higher recently. There's from the Association of Colleges, there's some statements coming out about whether we're putting all our eggs in one basket as far as higher education and engineering education goes, and whether that basket is becoming too expensive. That seems like a bit of a mixed metaphor to me. And lots of questions about how easy should it be to open a university, and even speculation about whether there could be even 1,000 universities in the UK. So hopefully plenty to talk about tonight. But the discussion will be led off by Kel Fidler and followed up by Karen Usher. Kel, many of you will know, is former chairman of the Engineering Council. He's a fellow of the Royal Academy and was until recently on the Education Subcommittee. Karen is one of the co-developers of a new university for Hereford, so we'll hear some more of the details about that from both Kel and Karen, who've got different perspectives on the same thing. But as I said, hopefully that will then lead on to a wider discussion, which all of you are welcome to contribute to. Timing-wise, I'm hoping we can have all said our bits by about 7:15. We've got a drinks reception then to carry on the discussion more informally after that until about 8 o'clock. So that's plenty from me. So I'll hand over first of all to Kel.
Thank you very much. Well, a very good evening to everyone. It's nice to be here this evening on such a beautiful November day, and also to try the rigours of Virgin East Coast, which had me in only 45 minutes delay earlier this afternoon. But I do have my claim ready to submit. I'm having trouble here because the laptop means you can't put any notes on this lectern without them slipping off onto the floor. So I'm currently trying to attach my tag, not my hashtag, to the computer. I want to speak a little bit tonight about my views, shared by quite a few people, on the way that engineering education needs to go, I believe, in the UK. As it happens, that resonates with what Karen and David and others are thinking in their work. The one thing that starts us off on this is the acknowledgement that apparently the UK needs more engineers. I say apparently for reasons which might become evident. The UK needs more engineers at all levels for sustainable economic growth, and they need to be good ones. And lots of people have been saying this. You've heard them: James Dyson, John Perkins, Royal Academy of Engineering, professional institutions, other employers. And many different numbers have been given as targets: 100,000 extra engineers at all levels, I've heard. But in the case of graduate students, which is what I particularly want to talk about, graduate engineers, people suggest that we should be doubling the number of graduates in engineering that we've had in the recent past. Oh, and can we do that please by 2020? And if not that, 2022, or as I've read recently, by 2030, as soon as possible, basically. So how have we been doing in the recent past in graduate numbers? And this graph shows us something about that. The trace here shows the overall number of UK domicile applicants to universities in the UK for all subjects. As you can see, it goes up and down according to economic fee and also the number of people in the age group. And it goes up and down, but there is a general trend for an increase in the number of students into higher education. If we look at this curve, it's first of all multiplied by 10 just to get it on the same scale, but it shows the number of students amongst those in this curve that have applied for engineering, DC, UK domicile. And what that shows is a similar shape to the one above, which suggests that as this goes up and down, engineering applications go up and down, there's perhaps some proportionality there. And the proportionality is actually shown by this. This expresses as a percentage the number of students applying for engineering as a proportion of overall student applications to universities. And for some, this is a somewhat sobering curve because it's more or less constant at about 3.5% over some 10 or 11 years. The data for this, incidentally, comes from University UK's annual report. So what we see from this is that if everything that we've been doing with schools, intervention in schools, with outreach, with fairs and so on, if it's been doing anything, it's been maintaining more or less the status quo. There has not been any significant increase over the last decade in young people applying for engineering. And for some, there's even more bad news. This shows the share of that 3.5% amongst the major engineering disciplines. So given that it's more or less constant at 3.5%, you might expect we'd see that the individual disciplines would also be constant. Indeed, two of them are. Aero engineering is more or less constant, and also general engineering as a university degree course is more or less constant over that period. This is civil engineering. Civil engineering was on the ascendant until 2008, when, of course, terrible things happened in the world economically, and since then it's been nosediving. Mechanical engineering, and how wonderful to say this within the Institution of Mechanical Engineers, mechanical engineering has been doing brilliantly well, and if there are mechanical engineers in the audience, they might like to tell us why. They have increased their share, as indeed have the chemical engineers. And I know the chemical engineers think that their Why Not Chemical Engineering initiative has been responsible for a lot of their success. But those increases come at the expense of this curve and also this. This is manufacturing. Important to the UK, it's nosediving in terms of the number of students who show any interest in it. And this is my own subject area, electrical and electronic engineering. That also has been nosediving for a decade or so, and it appears as if no one noticed that. The next curve I've got has normalised all those on the previous slide to 100, just to show what the successes look like. This is chemical engineering, which was 100 in 2002-3 and is now up to 2.5 times its share of that 3.5%. And also mechanical engineer has gone up about 1.25 times on that scale. But look again at how awful it is for manufacturing electrical and electronic. Now, my own view, held for several years, is that the problem in all this, the problem as expressed in that 3.5%, which has been more or less constant, is that many young people, but perhaps more significantly, many of their parents, many of the people in our society, many of those who work in the media, many of those who are politicians, lie in ignorance about what engineering is actually all about. As someone said, why would you send your son or daughter to university to learn how to repair a washing machine? Because that, unfortunately, so often quoted, is the level of ignorance about what engineers actually do. Worse than that is that those things worth noticing about the success of engineering are so often attributed to science. Science apparently is engineering, or if you want, engineering is science, and I'll come back to that later. What about the student intake? Well, if you plot the tariff point scores, where A star, for example, is 140 tariff points, and A is 120 and so on, and there are equivalent tariff point scores for other qualifications outside A levels. If you plot the number of programs with average tariff point scores of the students within them, in this case 300, there are about 55 programs in UK universities which attract students of that quality. If you plot that over the entire range of tariff points, that is the curve you get. Notice the incredible range. There are some programs up here where the students within those programs have averaged 4 or 5 A stars at A level. Do they exist, you might ask? Well, I've been on the scholarships committee of the IET for just over a year, and there are some students there who are offering as proof of their qualification for a scholarship the fact that they've got 5 A stars at A level. 54% of the scholarships go to students at Cambridge, and most of those have those sorts of marks. It's incredible. At the other end, there are those students who probably we could best describe as being qualified in the University of Life, or if you want, the Further Education College of Life, I don't know, or perhaps they just passed the breath test. The mirror did in fact cloud over when offered up to their mouth, as having, rather poor qualifications. There is a huge range. I have to say instead there'll be some sub-degree programs down there. There is a hint, you'll see, of a double peak, and the next slide shows how that comes about. What I've identified here are in blue the old universities pre-92 and their courses. The red is the post-92, the so-called new universities, and the green are the colleges. And what we see is that actually there are two distributions superimposed on one another with some overlap, where the lower qualifications, with an average of about 300 tariff points, belong to new universities and colleges, as against the average of about 450 tariff points for the old universities. The problem with this, of course, is that many of those students at the new universities, for whatever reason, and having been a Vice-Chancellor in a new university, I can explain it in one word, which is prejudice. The new universities, unfortunately, are attracting lower quality students because of problems such as that. They're often those that have gained entry through clearing. They have much higher failure levels during their first years. And it's a great shame, because if any of you have ever been involved with accreditation of engineering courses, you will know, as I have, I was chair of IE accreditation for 6 years. You will know, as I have, that the facilities to be found in new universities are so often much superior to the facilities which in some cases are found in the old pre-92 universities. It does seem that we have the capacity for good engineering students. It's just that we don't seem to be attracting them. And what about the background of these students? Well, most engineering degree courses would say they would like an A-level in maths and an A-level in physics. And we see here, and this is generally well known and rejoiced in recent times, that the number of students taking A-level maths has been on the increase, the number of students taking A-level physics has been on the increase, but this is the number of students taking both maths and physics, which is so often the double requirement together with another science or something that we find in UK universities for engineering. There are about 30,000 students who are offering both those qualifications. It's just come up to that number. That's to be compared with the 25,000 UK domiciled students that have gone into engineering in recent times. In other words, if we doubled the number of engineering students but required A-level physics and maths, they're not available and not going to be available if we look to see what is happening in the world of maths at school. And to make matters worse, as Charlie Stripp, who is the CEO of the Maths for Education Industry, explained, was it last week or the week before at the House of Lords event, there's concern amongst the professional teaching community in maths about maths teaching. And of course the government aspirations, as we know, are for everyone to learn maths to 18, and for 16-year-olds who fail GCSE to keep taking it until they're eligible to visit the job centre. And that would seem to suggest that we need more maths teachers. But despite reassurances from the DFE, it would appear that it's not necessarily going to be the case that we're going to get those more maths teachers. And also the changes in GCSE and A-level syllabuses and so on mean that some teachers in our schools are suggesting, and I was at a school giving a talk on engineering yesterday in North Yorkshire, and the maths teachers confirmed this, they're suggesting if we're not careful, maths is going to be a subject off the curriculum over the next decade. Now, I don't suppose that's going to help with the recruitment of engineers in the 2020s. Earlier this year, Matthew Dixon of Scope, I had to look that up. Scope is skills, knowledge and organisational performance. It's a unit at the University of Oxford, produced a research paper which you see here is about the scale of leakage of engineering graduates from starting work in engineering and its implication for public policy and UK manufacturing sectors, rather strangely presented. And he said this, and this stopped me in my tracks. The fraction of those graduating from particular engineering disciplines who go into the corresponding industry sector, and in particular within manufacturing, is not only not 100%, which I suppose we wouldn't expect, but generally less than 50%, and in some cases less than 10%. If you look in detail at his report, students who take electronics at university, probably only 7% of them actually go to work in electronics, and in particular the electronics manufacturing industry, upon graduation. Excuse me. Now, this is very disturbing news. If it's true that only 50% do that, then it would appear that our employers perhaps are just selecting away from the rump of the curve that I showed you. In other words, they're employing within the old university sector, and there is some evidence to suggest that is the case, or maybe something else. And this is what Matthew also said. It's not easy to support serious arguments that there might be any substantial shortages of engineering graduates, in particular in aerospace, electronic and electrical and chemical process and energy engineering. Now, it's understandable perhaps why he reached that conclusion, although whether this is due to this point that I've just mentioned, that employers don't consider the rump end of the curve, the histogram, when they graduate as being employable, or whether it's that the graduates had decided after their degree slog of engineering that engineering was not for them. Either way, it could be argued that our current engineering degree programs are not attractive to today's students and today's employers. And as Richard Martin, who's the technical director of Nestle, said when I met with him last week, when we take our new graduate recruits, he said, we effectively have to start again. Now, this is disturbing news. Many identify with the oft-quoted description of engineering degree courses as mind-numbing maths science death march that casts aside the thousands of capable young people who might otherwise have made effective engineers. This comes from an American body, the Big Beacon, a movement to transform engineering education, but quite a few people in this country are quoting, I'm one of them, are quoting this now, and quite a few people I've talked to have some sympathy with what is being suggested here. There are those that believe that many engineering programs in our universities are actually about science. Maybe it's called applied science, maybe it's called engineering science. And moreover, that their best graduates go on to do PhDs within those so-called engineering departments and then themselves become academics teaching the same subject and with all its scientific connotations, but rather away from engineering. There are those that believe there is not a continuum from science and maths to engineering, except in a small number of cases. I suppose the laser, the hologram might be examples of that, but rather that science and mathematical developments follow from the creative activities of engineers. The creative activities of engineers. As Petrovsky in America at Duke University has said in several of his books, there was no science of thermodynamics before the first steam engines were built. There was no science of flight aerodynamics before the Wright brothers constructed their first aeroplanes. Much of our science and mathematics actually follows the creativity of engineers. And my friend, Professor Kali Pistorius, who is the Vice Chancellor of Hull University and an electronics engineer, eloquently explained in his 1995 paper called The Perils of the Linear Curriculum, he drew attention to the fact that manufacturing engineering does not have a scientific or mathematical base. You do not teach some science and some maths and then go on to teaching manufacturing engineering. Teaching engineering as a development of science and maths is, some have suggested, not teaching real engineering at all. At the heart of engineering, I would suggest then, is creativity. Creativity, Sir Ken Robinson, I don't know if you know of his work, he's got a lot of YouTube videos and TED talks and even RSA talks. Ken Robinson has suggested that creativity is having ideas that have value. He's called it applied imagination, which for me is going a little bit far. And he also talks about innovation. And innovation is about taking ideas that have value and turning them into reality. In other words, from an engineering and a product perspective, bringing them to the market. Innovation clearly follows creativity in real engineering and is another aspect in which our students rarely engage. Do our students, for example, engage in creativity? Possibly in final year projects, although the creativity bit, in my experience, is often done by the supervisor. And it's for the student to carry out the proof of concept or technical validation stage, or as Kali Pistorius describes it, the invention stage, to show that it's something worth patenting. But invention is not innovation. Innovation is about bringing things to market. And it can be product innovation, which is self-explanatory. It can also be process innovation in terms of manufacturing industry, or technological innovation in terms of bringing technology together to solve particular system problems. So creativity and innovation lie at the heart of engineering, I would suggest, and as suggested by Sir George Cox in his 2005 report, creativity links to innovation through design. Yet many engineering degree programs, in my experience, pay scant attention to design. And if they do, often as a specialist option, the tendency is to concentrate on design for function, ignoring those other essential aspects. Oops. How has that happened? Those other important aspects of design for form, for manufacture, for maintenance, for disposal, and obviously the approaches there are to teaching that design. So I can see a brave new world of engineering programs away from that linear curriculum of the death march of science and mathematics, then leading to the so-called engineering, or a pale replica of it, towards teaching creativity through design then to innovation. And inspired by and building upon Rick Miller's distinguished lecture at Warwick University a couple of years ago, I give you the three abilities leading to design and innovation. To design a product and bring it to market, we must first check feasibility. Is the product technically feasible? No perpetual motion machines. Is the product technically feasible in terms of the technology that is around, and so on? And then, yes, does it satisfy scientific and mathematical principles which model its performance? Next, we must check viability. Is the project legally acceptable? Does it require sensible financial, real estate, human resources, and health and safety provision? And finally, desirability. Is the product desirable? Does it meet aesthetic, societal, ecological, and ethical requirements? Clearly then, if this is innovation within engineering, engineering goes way beyond science and maths. Engineering embraces design, economics, finance, human resources, real estate, health and safety, marketing, ecology, quality, art, psychology, sociology, ethics, and so on. A real potpourri of topics that constitute a liberal engineering education. And this is the education which can appeal to so many young people with backgrounds and interests from a much, much wider spectrum than maths and science currently provides. So this is the big idea for engineering education. Appeal to a much wider pool of student applicants by relating their wide spectrum of backgrounds and interests to the realities of engineering, its omnipresence, its ubiquity, and its role in society globally. It's a big idea which is being embraced in various manifestations by Olin College and the University of Illinois in the US, and by UCL and the up-and-coming University of Herefordshire. They are just a few of many more which I know Karen is going to tell us about. So, with apologies for my voice, I'm suffering from man flu, as you might have imagined. That is what I wanted to say by way of an introduction, and I now give the floor to Karen.
Thank you very much, and thank you, Kel, for setting the tone on that, and thank you, UCL, for the opportunity to talk a little bit about this. The last 3 years that the project in Hereford has been working on trying to identify exactly what and how we're going to teach young engineers for the future have led us into a series of questions, much of what you've heard from Kel tonight, but also driven by asking two really pertinent questions. Why and why not? Why are we doing what we're doing, and why are we not trying other things? So the numbers, my headers aren't missing. The headers are missing. Oh, yeah. The numbers, which it should say at the top, the numbers are really not good. We have an industry that produces, or a profession that produces approximately 1.17 trillion in revenue every year. We have a ratio of about 5 openings, so industry tells us, for every engineer that universities are producing. We have a future that talks about 2.56 million engineering openings projected in the next decade. That's openings, that's not new positions, but turnover, of which some 220,000 new positions or new graduates are required by 2020 alone. That's the 220,000 by 2020 number. The average age of an engineer, 58 plus. Interestingly, when we started this project, it was spot on 58, and it's slightly beyond that now. The number of women in the profession, 6%, not a happy number. The number 2%, that's how many parents are willing to tell their daughters that they should consider an engineering profession. 12% is the men. 20% of young people who would think about engineering if you just sit them down by themselves, versus 75% who would think about a career in science. So we have a bad bunch of numbers, but the comments, which is what the top should say, from the public and others are even worse. So comments are from the public about, we don't know what engineering is. We don't know why we would want to have more students in engineering. The comment from parents about not wanting their daughters or their sons to enter the profession. Prospective students, young people, who when you ask them what engineering's about, say, or my neighbor Ollie, who's a petrol head, says, engineering's about running trains, isn't it? Employers who won't take engineering graduates because of the amount of time that needs to be invested in making them work ready and productive. Engineering students, the worst one I've heard in 3 years, coming out of a well-known California engineering institution, described by a young woman, engineering, the jihadists of higher education. They hate women, they torture people before they convince them about joining their cause, and they don't live in this century. That's a bad comment, really bad. So these are the institutions, some of the institutions around the world, who have begun to tackle this project, this problem with engineering, its image, its way of developing students. These are some of the institutions that have begun to think about, how do we teach differently? How do we produce a student who is engaged, who is passionate and interested about engineering? These are the radical transformers of the day. And some of the names you'll recognize in the center here. Some Kel spoke about, some we are working with, some we are learning about even as we speak. These are the revolutionaries. They're exploring new pedagogy, new approaches to classroom delivery, new curriculums that speak to young people. And they speak to the world in a different way about what engineering education can be in the 21st century. So they are working, sorry, the headers are all missing from this, so I apologize, at capturing the best. So the project in Hereford is working to capture the best from all of these, and to capture the best from what the UK is in fact doing. And we intend to create, in essence, a laboratory for the nation to look at some of these new methodologies in engineering education. Olin College of Engineering and our partner Warwick and our advisory partners, including Bristol, are coming together to create this laboratory to bring these new global education practices together with Britain's world-class engineering content. And we're going to be doing things quite differently. We're admitting students differently. We're establishing and delivering a very different kind of culture, teaching differently, assessing differently, and never forgetting the critical importance, the core critical importance of a quality engineering education. So what does this mean, admitting differently? We're talking about, in the last 3 years, we've engaged with 4 sets of transformative input. The first is admitting differently. The groundbreaking institutions from the previous slide, the parents and students, employers, and equally importantly, the education community at all levels and all perspectives is looking at this differently. So in admitting students, we're going to be looking at the whole person, particularly identifying and assessing to look for what we're calling, and we're working with the RAE to talk about, learning habits of mind. A different way of assessing the kind of skills that students need to develop in order to become good engineers, the rigor that they need, the ability to assess and analyze. We'll be looking for those. We'll be looking not requiring maths and physics, and we're joining with a growing number of institutions who are not requiring maths and physics, but still looking for very good students. These are students who have studied rigorously other subjects, but across the board. They could be studying almost anything and demonstrating these learning habits of mind. We'll be looking at women, service leavers, and apprentices, and saying, what is it that we need to do to bring these very capable, very talented people into the engineering world? What's holding them back from coming in now? And what is it that we need to do to invite them in? And also looking at the career developers, those people who have been in industry, who have been working, who are looking to upskill. In fact, we've had several conversations with major employers who've literally said, we are very happy to take your graduates, but we're also very interested in asking if we can send some of our engineering talent back because the profession has begun to change and we need those people developed as well. So in essence, we're looking for a combination of curiosity, grit, and passion, not necessarily A-levels in maths and physics. So, culture, a different culture. We'll seek to create a new type of academic institutions where students know it is a culture of excitement and inclusiveness, where it's safe to fail, and safe also to super excel. In this country, I find it absolutely amazing that a student can be halfway through their program, leave it because they've come up with a great idea and started a business, and it's considered a failure by the system. Whereas what we're looking for is the ability to celebrate those students, keep them engaged with the process, and let them go, because they'll come back. They do all over the world. Collaboration in the classroom from day one, from the day students walk in the door. Collaboration between students, faculty and industry and students. We're looking to bring the classroom closer to work, but still keeping it very much focused on education, but closer to where students will be going when they leave. And this will be an institution owned by its faculty and students, a nonprofit, but owned by its faculty and students. So developed on their behalf, with them, for them, and they will have a lot to say about how it's developed, and embedded in and balanced by the community. Again, students who are involved with their institution, involved with their community, replicate the world they're going to. So it is real-worlding higher education, bringing them closer to what they're going to be asked to do when they leave, as they learn. So, sorry again, header missing. Teaching differently.
Try different version of the slides, or?
No, it's okay. I think we're fine. Teaching differently. That's what the header will be. And because that's the focus and where the rewards lie. So this is a teaching, undergraduate teaching institution. We will be doing research, but it will be research and innovation. And it'll be research in how to teach more effectively. And we will develop a system that provides a strong focus on teaching, and rewards for great teaching. Deep integration of engineering, humanities, and core business knowledge, including that very critical element of design. So looking to develop engineering students who have the breadth and the knowledge and experience by working with industry from the very beginning, and looking at humanities and incorporating that in the core of what they're doing. I mean, I do not understand how we can say that, for example, an engineer working with fluid dynamics and water who works in the Middle East cannot know a little bit about the history, the politics, the religion of the Middle East. How do we do that? How can we say that that's not important? It will be interdisciplinary, therefore, at all levels, focused on the application of what students are learning. Embracing technology for content and customization. We have tools that we are not using effectively in the classrooms. We need to free the classroom for learning, for the coaching that great teachers can provide, and use those digital natives. Let them use the technology the way they are already using it, and bring into the classroom the concept of teaching again, learning and doing, so that they can learn to apply and develop. Intense, meaningful, practical, 46 weeks a year, taught in block, 4-year degree, Eng in 3, including their internship. Why? Because that's the world they're going into. So learning to become a liberal engineer. Assessed differently, that's what that should say. And to make sure that we accomplish what we've set out to do, we need to assess for competence. We need to assess the students for competence, we need to assess the teaching faculty for competence, we need to assess the institution for competence. Are we delivering what it is that the students say they need and what it is that industry, the other customer, says they need? Which is rapidly productive employees. Employees that do not require, as Kel's colleague at Nestle indicated, reteaching once they walk in the door. Literally being able to say to an employer, I can tell you how much, if this individual takes 9 months to onboard, I can tell you how much out of pocket this costs. And by the way, it costs just short of 3 years of education for most engineers. It is a quantifiable amount of money, and we need to help those young people, both for their own interests, for their connection to engineering, for their desire to contribute to the profession. We need to help them come on board more rapidly. And that's what employers want too. They need to be recognized for their quality, commercially or academically contributory, whether it's the institution that's being assessed or the students. And they need to be good citizens, ready to contribute and frankly change the world. So, none of the pictures are going to show up. So who are we? Who am I? Why am I talking with you about this? I am neither an educator nor an engineer. I am a parent. I'm a grandparent. Or I will be a grandparent and one day. I am a citizen of the world, and these are the people we need to be thinking about. These young ones are who we need to be developing this for. And if they're doing this now, at this age, we need to be developing curriculum that allows them to take that through at the university level. So Hereford, who are we? Our intent is to help all of us redefine engineering for a whole new generation. Students with high quality applied engineering education, educated within a culture that produces highly ethical, innovative, interdisciplinary, globally aware graduates, led by a constantly evolving employer-informed curriculum, interdisciplinary, focused on helping these young people apply their skills to the world that they're working in. Inspired by outstanding teachers and practitioners in the classroom who motivate and develop those skills, not lecture at, but motivate and develop, and create the problem-solving breakthrough employees and innovators of tomorrow. And we aspire, quite simply, to be the best new university for applied engineering education anywhere. So, a little bit about us, a little bit about some of the ideas we're beginning to do, and we would look to you guys to talk tonight about your thoughts about what Kel has said, what we've said, and come help us, come learn with us as we develop this institution over the next couple of years.
Okay, so thank you very much, Kel, thank you very much, Karen, and I should also say thank you very much to the IMechE for hosting us this evening. I should have said that at the beginning, we're really grateful. I think they've set the scene really nicely. I think there's all sorts of some threads for conversation. So really, it's over to you now folks, who'd like to lead the way. So it's a difficult one. Thank you very much.
I wondered, you talked very much about opportunities perhaps for flipped learning and digital learning, but there wasn't much about work-based learning, part-time learning, and the demand we've seen more recent years, particularly for the part-time. I wonder what
it's right at the center of what we're doing. Yeah, a 15-minute gap to fill, but it's right at the center of what we're doing. This project, as many of you may know, started around the concept of how do we develop new talent in and around Hereford and Herefordshire County. And the employers said to us over and over again, we need not just new talent, more skills, but we need to upskill what we've got. And so at the core of this is the ability, particularly as we start within Herefordshire, to provide access. And one of the reasons for selecting the block methodology of teaching, which if those of you who don't know, is instead of teaching a linear course over a period of multiple weeks, it's or the whole term, it is a concentrated 2 to 3 week period on the subject and topic. And that, interestingly, has produced great interest from industry, both in terms of them providing practitioners in the classroom, but also the willingness to release an employee for 3 concentrated weeks to come in and refresh or develop new skills. So yes, part-time is very much at the core of it, although we will be not building a part-time institution.
Okay, thank you.
I spend a lot of time wandering around universities talking about how to teach sustainability and creativity, and the thing that I get kickback all the time from the staff is that we're working really hard. We don't have time in the curriculum with all the technical stuff we've got to teach to bring in this new material. Now, you are widening the curriculum, so what sort of things do you think you would not have in your course?
Do you want to?
Yeah, but rather than it become too much of a question answer thing, I think that's a really interesting question. I think Peter,
Peter, maybe you can.
Yeah, I mean, what would we not put in? Well, if you look at the recent Royal Academy report on what attitudes make an engineer, it's a set of attitudes that make an engineer. It cannot be content, because if you look at the hard technical overlap between the technical content of, say, a computer engineer and a water engineer and a fire engineer and a electronics engineer, there isn't actually a huge amount of content that they share. So it isn't that makes them an engineer, it's a set of attitudes and approaches that makes them an engineer. That's what we want to focus on. That's why Karen didn't say it. The proposal is no disciplinary divisions, no departments, no faculties of this, that and the other. And essentially, you could deploy a set of engineering attitudes anywhere. Now, what we're currently engaged in, and we'll Kel and a number of us are having our second meeting tomorrow morning on this, is okay, so what does that mean in terms of what you don't have to do? And this is a hard question which we've got to address, but starting from the fact that not all the entrants are going to have mathematics at A level, that's a starting almost given for us. We've got to tease out what is really needed. Interestingly, I did a survey in my own ex-university, Liverpool. I asked every teacher of the first year of the programme, could you give me a small number of concepts which your course, your module, gets across? Do you know, nobody had more than 3 in a course or module which lasted probably 15 weeks. Nobody could give me more than 3 concepts. Now, if we got those 3 concepts across, we'd have done a bloody great job, and I'm sure it doesn't take 15 weeks if we've identified what are those key concepts. That's a sort of approach I think we have to adopt.
3 observations I'm going to think about that. essentially very excited about the things that you're identifying and starting to put into place. My three observations, and this is largely based on a period of time spent in organisations in the vocational sector. We're increasingly referring to it now as technical professional rather than vocational, because I think there's all sorts of baggage associated with vocational in terms of trying to establish any sort of equity in an academic track, which isn't always helpful. So first on the supply side, which I think you touched on, I just wondered to what extent the sector has been honest with itself about its reflections on what it's looking for from applicants coming into university, schools, current graduates and university intake here. Because again, all the references to A levels and A star and all of those things, to what extent are we aware of core maths, are we aware of technicals as being programmes of study in 16 to 18 which are intentionally supposed to include placements and exposure to the work, which then perhaps makes them more work ready when they come out at the other end. Because I hear every day about employers saying that graduates are not work ready. To be honest, anybody going to the workforce from day one is unlikely to be productive from day one, whether they're 16, 18 or 21, 22. So I think there's a bit of management there of expectations in terms of what you're delivering into the sector. The other observation then is about, we touched on before about the concepts of placements within programme. So I think again the observation I would make is that a lot of perhaps some of the failures in the system is the abstract concept of engineering delivered through science and maths as opposed to the applied context of engineering, which therefore gives people a better grounding in how they apply their knowledge when they do graduate and come out from there. So I think it's, and then the final point about this mismatch between this lack of engineers that we've got. One of my observations there would be either there isn't the lack that people suggest there is, because otherwise why are only 50%? Is the 50% sufficient? Or are employers actually getting their workforce from somewhere else? And that's what they talk about when they say the gap of engineers. So that wasn't entirely clear whether there truly wasn't a gap or whether actually they're recruiting from somewhere else because they're not seeing sufficiently skilled, able students coming out of the UK.
Yeah, I saw a graphic that Rhys Morgan, who many of you will know, put up last week, which shows people who are identified as working in the engineering sector come from a hugely wider gene pool than we would imagine if we just keep talking about pre-92 academic institutions. And I think one of the things I took away from Kel's slide is that the system may be a little ossified, but maybe a question we should be asking is, with exciting developments that many of you represent and are talking about, what are going to be the agents of change? What is going to make the students who would otherwise have gone to University X go to the Hereford instead? I don't know if that's something that...
With regards to students in schools, again, one of the things that we've spoken about several times recently is we should be too critical of the teaching profession's ability to advise on careers. Most teachers are graduate teachers. Their only exposure to career is school, higher education, school. So why would they have any view about advice to offer about what breadth of opportunity their lives in an engineering career? I think this is where, in some ways, the industry needs to be far better as well at reaching down into careers advice to support the breadth of opportunity that does lie.
Can I just say, yesterday I visited Lady Lumley School in Pickering in North Yorkshire, and I had over 200 people in my audience from the 2 sixth forms, and I showed slide after slide of engineering products. I showed the F-type Jaguar, I showed the Milau Bridge, I showed all these sorts of things, and explained to them that engineering was not just repairing washing machines or installing broadband in your home. It went over all those things. And all the teachers that came out to me afterwards, and this is not a unique occurrence, it's happened in all the other schools I've been to, said, thank you, because actually we didn't know that was what engineering was about. And it's so nice to hear someone with an engineering background tell us. I had 2 students yesterday who came out who, I got the impression from the teachers are amongst their star students, who said, thank you very much. They said, you made us think. We've both applied to do maths. I think at Oxbridge we're now wondering if perhaps we could do engineering instead. And if I look for triumphs in what I do in Speakers for Schools Initiative, that is the triumph I look for. Can I just say while I'm talking, that another point you made, which is dear to my heart, is that the Engineering Council, of course, which regulates the engineering profession, has its UK spec, the United Kingdom specification for professional engineering competence. And all those who become chartered engineers and incorporated engineers need to meet the requirements of that. One requirement of that is that you should have an exemplifying qualification, which is, for chartered engineer, an MEng in some subject which is appropriate for engineering. But that is only the start of it. Rather like doctors going into teaching hospital, we expect our graduates to go into industry and to continue what Finiston said in his famous report was the formation of the engineer. But I don't think that meant that we should be pushing into industry people in my subject area, electronics, who can tell you all about Maxwell's equations or Schrodinger's wave equation and so on. We actually need people who can talk about actual engineering and not just the maths that goes with it.
Anybody else like to?
Yes, I'm Peter Wiley. I'm the Director of Education for the Baker Deering Trust, and we are establishing university technical colleges in very small numbers, but persistently up and down the country. And most of them are engaged in engineering education in the broadest sense. Some of them very specifically, but some of them more generally. And we've been struggling, as you all do at university and as employers, with these issues. And I think we've got a number of insights which are worth sharing in this audience. I mean, I think the first insight is that most traditional bits of work that sit between universities, employers and schools are not actually sufficiently real life for young people to engage. You know, we've got a really good project running at the moment that's run recently with the UTC in Reading and the people who are building the new Network Rail station at Reading. And actually, those consulting engineers would say to you that the designs the young people came up with were better than the ones that they were originally going to work with, because they were free of preconceptions. But we've, I think, got two insights into. So that's one insight into, you know, really do trust the youngsters to even at 14 to come up with ideas that challenge the preconception. The second thing is that we are struggling, like all of you, with gender balance. And one of the things that comes across very clearly to us is that it's, back to your point, it's about the ethical dimension of engineering and the solution of ethical problems and ethical dilemmas that actually not just gets more young women interested in engineering, but it actually gets more young men who are thinking altruistically about being involved in engineering. And if we can get people to see that this is not just solving, you know, traditional real life engineering problems, but actually it's about how do we feed the world in the next 20 years, you know, or how do we work better on disaster recovery and disaster relief, that actually is what sparks the interest in engineering as a conceptual framework and as an ethical framework. And that actually produces some really very, you know, if you look at the destinations from UTCs, they're astonishingly good in terms of entering to higher education and entering to higher level apprenticeships, particularly in engineering, because actually of those two insights.
Yeah, that's a really useful contribution. And UTCs are a new model of engineering education?
They are, and everybody hates us except for universities and employers.
Yeah.
University employers think we're great, the system thinks we're dreadful.
Parents like them.
Parents like them. Parents like
Do
them.
you want to speak up against that? Oliver first, I think.
Well, I think this point that came up in the presentations about how actually think about engineering as design. What does design do? It's user-centered. It's about creating, rapid prototyping, making something in the real world, then going back to the drawing board. That sort of thing I think works particularly well in maybe software and possibly in chemical and those subjects which are on the ascendant. My kind of hinterland is civil. engineering, which is clearly on the out. You know, we're going to have no buildings left on this side. And their prototyping is difficult. We've tried it. We were involved in setting up Construction Area 10, 15 years ago. We've done a version for UTCs called Build Camp, which is about building a railway in a week. You can do it, but you need to have a space where you can build. So you actually need to be able to pour concrete and steel and knock it down again and rebuild it. But I really think it's a bit of a barrier. You need to have partners involved who will help you build stuff, technicians, whoever they are, people who will allow you to bring the materials into the classroom. And I think therefore it maybe means you need to change the environment. The environment is actually a workshop, not a wooden sort of lecture theatre.
Exactly, and it is why, for example, that most of those universities that you see up there have no lecture halls, seminar rooms and labs, and the rest of the work is done out with their employer partners.
Right.
So it's actually bringing the real world into the classroom much more and taking the classroom out into the real world. And that's very critical to making this work properly.
Graham,
I was going to respond to a question earlier about where the engineers come from. An awful lot of them come from higher national certificate and diploma programs. And employers tell us constantly that they're very happy for people to come in at HNC level and then move through the system. And these are young people that they may have come from Wolverhampton, where they've got one maths teacher across the whole of Wolverhampton. They're not going to come in with good maths grades. Don't expect it. They're late developing. They need nurturing. And talking about them as sub-degree programs as if they're another species isn't helpful. We need to embrace them. We need to give them a route through. I mean, you come out at level 5, you're nowhere. You're not a technician engineer. You're not an incorporated engineer. You're just somebody in between. Because the profession, the Engineering Council, doesn't really recognise that level. So there's a lot that could be done with people who are working at sub-degree level to encourage them and to give them routes into the high-level engineering profession, because at the moment they're doing very good jobs with employers in their hundreds.
Yeah, and many of these institutions, particularly the US ones, have picked up on the model that I think is something that this country could develop. Clearly I'm not from here, so I bring a perspective that's different, but I mean, in the States, if you have work-life experience and you want to move to the next level, whether it's an apprenticeship or just plain work-life experience, you go to your local university, you say, here's my portfolio, here's what I've done. The university assesses you and says, of the 480 credits you need to graduate, we're going to give you 120. You know, it's a very simple formula. Here, it's so complex and so gnarled up that even those who are specifically established to help navigate that pathway can't explain it in under, a manual that big. And we've got to deal with it. And you cannot double and triple the number of people going into industry unless you actually double and triple those that you'll consider for this. And you just can't.
Yeah, so we're talking about sort of mobility and thinking beyond the way we do it at the moment.
Yeah, and you're absolutely right. They're great prospects. They bring that work-life experience into the classroom, so those who don't have it get to benefit from that as well.
Could we add to that point though? Because one thing you didn't mention under assessment, I think one part of our vision is that the student on graduation, having gone through whatever assessment we should have that portfolio. There should be something to show, something that they've done, and it might be an art students type portfolio, or more likely to be on their laptop, but it will be something they've done. Not just even the higher education achievement record or whatever it's called, which is supposed to be a bit better than our classified degree. That still is very dry compared to here's something I designed, better still, here's something I built, better still, talk to these people who used this thing that I built. And we can get a fair way, I think, along that path.
A lot of this is about looking at how the profession talks to each other, to students, and to employers about the profession. My background, as I said, is not education and it's not engineering. I've spent 30 years in human capital development and human resources. So I've been at the consumer end of this. Same problem in the States that you guys have here, numbers are not good. But when we say, for example, students aren't work ready because they can't function effectively in teams. When I say that as an employer, and you say about whether they're working in teams while they're in education, I've discovered that we're not talking about the same thing. What I mean by working in teams and what you say about how students have worked in teams as students are two completely different things. And so what's critical to solving this problem is to putting people together and actually talking about what they mean. And so in the concept of assessment, at the end of an educational period, what I need as an employer is what answers what's on my job description for what I need. I need somebody who can do these things. And I need a student who can say to me, I know what those things are. Here's what I can do to show you that I can do those things. That's the language we need to begin to develop. And however we choose to assess students going forward, they need to also understand that language so that when they go out to the workplace, they can talk in the same language that the employers are talking.
We've got just a little while longer. A couple of you I've spotted with hands up. But perhaps I could invite you, in framing up what you're about to say, is that to think forwards. There's been a lot of discussion, and probably this very room has heard a lot of them, beating ourselves up about the washing machine question and the maths and I think we're doing quite well to avoid that conversation. But let's think forward. Where may the world go? If Joe Johnson gets his way and new providers come in and some of us are caught a bit flat-footed. A few interesting things that Karen mentioned. I don't know if anyone wants to pick up on them specifically. Fast-track degrees we're talking about. We're talking about an organisation where research isn't the primary objective, but there's a big focus on teaching. So maybe those are one or two things we can pick up. So in no particular order, I don't know if what one of you two, Katie and your neighbour, had your hands up earlier on, and then we'll sort of work our way around to here.
Rob Best. It was interesting what Cal was saying about the Engineering Council, because I had some hand in the formation of the UK spec in its most recent version. UK spec has been drawn up with great consultation with higher education, with industry, the professional institutions. So it's an agreed formula for what constitutes a fully formed engineer. And it categorises the competencies into 5 particular areas. The MEng exemplifying qualification broadly meets the first 2 of those 5 areas. It seems to me that what you're talking about actually is a greater spread of those 5 areas in the degree output. And if I've understood that correctly, the question that arises is very similar to one Oliver posed at the start, is what do you do about the rest of the A and B competencies in particular in developing those post-graduation.
Do you pick on that very quickly?
The A and B competencies, for those who are not familiar, the understanding skills, the mathematics, those more technical things that I think have to be suppressed in the curriculum that you're talking about.
The answer is we don't fully know yet. And until we actually begin to work with the various different bodies to figure out how to characterize that, we don't know the full answer yet. What we do know so far, and I think maybe David, you could speak a little bit to this because you've had more conversation with them than I, is that there's a distinct hunger to try to figure that out. Because what everybody acknowledges is that industry is looking for something different. They don't want single disciplinary engineers anymore. They do want some of these skills, and we need to figure out whether it's a partial certification or a partial, acknowledgement of movement toward an end result that may come later with industry experience, or what we just don't know yet. But we have to figure it out because it is a major roadblock in addressing how we deliver this workforce of the future. I mean, David, I don't know if you want to add to...
I don't think I can add much to that, other than we're starting on a journey, and if people want to come and join us and help the discussion, they're very welcome.
That's a good answer. let's carry, yes, it's on the road behind.
Michael Stevenson, I've been working with NMIT for the last few months, just helping develop strategy. But I'm interested in the concept of STEAM, which we haven't mentioned today. It's pretty hazy. People don't do well when they try to say what it means. But it seems to me that we actually have in the middle of that word E for engineering and A for arts beginning to compete with one another to relate to science and mathematics. And certainly, you know, we could be having today's conversation, Kell's syllogism of creativity through design for innovation, in a very different place, at the Design Council or Nesta, and it would be people from the creative arts who would be saying, we're the people who want to develop solutions for real world problems, for real world people. So it may well be that part of your question about where is all this going is a grander alliance still, you know, not just scientists and mathematicians with engineers, but drawing in people from the creative media and the digital economy. If we don't find a way to come together, I think there could be quite a difficult battle, really, a sort of CP Snow battle about who gets to figure out solutions for 21st century people.
Yeah. So there's a lot of people sort of nodding.
Thanks. Jan Peters, I've been working with the IEP, looking at creating inclusive teams and helping students to communicate with each other, but particularly to involve every different kind of character within the team. And we've been using the Gallup Strengths Finder tool to do that. So I was really interested, Karen, in your mention of culture, and with so many overseas students, a great opportunity for using the cultural context for conversations. So I thought that was really great to hear the way that you're doing that. I wondered if you might mention talk about how you're looking at addressing inclusiveness, more specifically, and also in terms of addressing and involving and keeping and retaining the women as well.
It's been a very interesting conversation. I think it's sparked by our original meeting with Rick Miller at Olin College when who was 50-50 and who I said to him, so, you know, it was easy up front, you had a lot of scholarships, you could sort of pick and choose, but how have you sustained it over time? He said, he kind of looked right and looked left and sort of said, don't tell anybody, but we've got a secret weapon. And I said, what's that? And he said, we simply asked them to come. We've simply said, this is a great place to come and study, you know, engineering as a woman. And what we found is that once they got here, it was a great place, and we've had to do this and that to sustain that. But the secret is simply saying, we're setting out to do this, and you know, we'd like you to join us, we'd like you to be with us, we think you're important. And interestingly, many of the institutions that we've talked with who have a much better gender balance, including here at UCL in the integrated arts and sciences program, where with the engineering focus, they have a higher number. And again, it has something to do with a combination of asking and saying it's a great place to come, adding some of the, we were talking about this before the meeting tonight, adding some of the cultural, ethical, design, servicing, giving back elements. And it does attract, I don't know who was saying men in as well. It is a very interesting phenomenon. This is a young generation. The way I say it, it's the post 9/11 generation. They're burdened. They see what they have to work on that we're leaving them. Trying to link engineering to that is what we've got to do. We have got to explain to them that the solutions of the things that worry them most, or the opportunities that they're most excited about, are almost all have at the core engineering. And it's developing that language, and I think that and removing some of the barriers that we have inadvertently put in place. You know, I don't think anybody intended to have maths and physics keep women out. It's happened.
Okay, folks, we really are coming to the end of our thing, but there's a few people who haven't spoken, so if I could invite you to speak quite quickly. Matthew's had his hand up for a while, I'll come to you. So Matthew first, and then...
Okay, mine's real quick. I think engineers come in two types, those with experience and those without. I think many of the preconceptions and things we've worried about here have been about young people who make up most of engineering, higher education UK, and actually higher education UK. And our worries, which are quite legitimate, really do apply to young people. They don't apply to people with experience. So if I feel that I'm an engineer and I rock up to an employer and say, these are things that I can do for you, no matter whether I look diverse or not, I'm in.
Yeah.
And then you get the paradox of the leadership teams of my organisation, another great engineering organisation, very diverse, but our recruits from university come from maybe 5 different faculties. So your point of, and what can we do in the future? Maybe we learn some of the patterns of behaviour when it comes to recruiting experienced folks and try and replicate that experience.
So I'm Debbie Chatra. I'm an associate professor at the Olin College of Engineering. I'm in London for a few days.
Yeah.
Despite what Rick said, hi, how are you? Good to see you.
I'm sorry. I'm sitting here going, I know you.
I'm quite out of context, also within context. So the one thing I want to say to your point, and Rick, we have a secret weapon, we just ask them to come, is that this is not a build it and they will come situation. That the other reason why women do really well at Olin, besides the fact that it's 50% women, is because we work extremely hard to make it continue to be a welcoming environment for them. And there is a massive commitment on the part of the faculty and of the institution. There are a number of us who do research on gender and engineering education, including myself. This is, what we're really after is if you do not consciously work to make it an inclusive place for women or for underrepresented groups, even if you start, because I think we thought the same thing. It's like, well, we're half women, we're a brand new engineering school, we have no legacy of this being a male-dominated place, and it is nevertheless true that the woman would have a very different experience than their male counterparts. So we work really hard to get them to think about these issues, that the faculty are aware of these types of things, so that we don't inadvertently do a bait and switch, that we don't have them come to Olin thinking it's a fabulous place for women, and have it turn out not to be. And this is one of the things that I think about in terms of sending my students out, my alumni, out into the workforce, that we can say, engineering is fabulous, why aren't women in engineering? And then they go into engineering, and the data shows that women leave tech by typically around the age of 30 as a result of years of basically dealing with gender issues in the workplace, and it being made very clear to them that they'll never have the opportunity to succeed in the same way as their male counterparts. So the point that I want to get across here is, and the other thing I need to say is, we do gender reasonably well. We do not do underrepresented minorities well at all, right? We see this as sort of our next frontier in terms of making inclusive, welcoming environments for a broader base of students. So really what I want to get across is that it's not enough to say we're going to create this, we're going to create the numbers and the parity. This is an active process that you need to be engaged with, both in higher education but also in the workforce.
Yeah, it is the policy, the procedures, the process.
Yeah. It is the culture.
It's the culture.
It is the student life and how things are handled there. It is, it's so much more than just the numbers.
Yeah.
Okay, so I'm gonna Katie, and then Phil and John, and then David.
Thank you. So Katie, I'm from Engineers Without Borders UK. A lot of the things that people have talked about today, we've been around for over a decade now, and 50% female membership, lots of engineering in context, a lot of the kind of ethical and humanitarian side of engineering that we think brings people to our organisation. But I think, I don't know if I'm allowed to ask a question now because of time, but my question was going to be that really excited about the prospects of what's happening at NMIC, but it will only ever be one institution, and so I'm wondering, given that there seems to be even more of a groundswell, but this conversation has been happening for, I'd say the last 10 years, if not longer, in terms of the change that's required in engineering education. So what will it take to get the rest of the engineering institutions in the UK to kind of do something?
Well, you put it far more eloquently than I managed to earlier on. I think that is the question that hopefully we started to make a bit of an impact on, and we're not going to finish it this evening, are we? But hopefully that energy can carry on forward. I mean, my sort of characterisation of it would be that the Hereford adventure is something that a lot of us are eagerly watching to see what happens, and maybe you are leading the way.
And we have made a commitment along with Warwick to follow the pattern of Olin, which is to share, to do this in an open book way, so that those who would like to join us both at the development and through on the delivery are welcome. This is not something that we want to hold. This is something we want to give.
I just want to pick up on the point of no disciplinary boundaries, because I can see how that unlocks innovation and so on, but where we are at the moment, the disciplinary boundaries are a key part of engineering assurance. If you take them away, there's a risk of anarchy, because you create an infinite number of interfaces, potentially, and more interface equals more risk. So I can see how the type of institution proposing works in terms of, for example, manufacture, new product development. I can't see how it works for delivering a traditional engineering project. Particularly if everyone's come through that learning experience.
Well, first of all, I would argue that probably a little anarchy would help us all. And in fact, if we don't add a little anarchy, I think we're going to be sitting here having this discussion 10 years from now. Having said that, I think this is something that has got to be revolutionary, but recognizing the importance of what we do, or what the engineering field does. And so it cannot be totally anarchistic. It has got to begin to put checks and balances in place to make sure that the quality is there, because we cannot ultimately produce somebody who's responsible for a bridge that hasn't got the qualifications that are needed to keep that bridge safe.
But we won't be producing all the UK's engineers.
No.
None of you will anyway. David.
That's a thought.
I have an observation and a challenge. And the prelude to the observations that Paul said a few minutes ago about Joe Johnson and opening the market up. There's another side of Joe Johnson's current preoccupations with higher education which is actually quite worrying. Okay, that's the teaching excellence framework. Now, I'm not against teaching excellence framework itself, but the teaching excellence framework alongside the research assessment get forged together in funding terms. And when that happens, the way it's being rehearsed, as I'm a head of department in UCL, the way it's being rehearsed, and I hear it with other colleagues as well, is that this is the strap line, how do we teach research better? And if you do that, it's completely against everything that Karen and Kel actually talked about this evening. So there's actually a challenge, in addition to the one that you're posing to us, which I think is absolutely fine. Okay, I think there's a challenge for all for any university department or engineering or anything else for that matter, of how they don't go down a mechanistic a response to the fusion of the TEF and the RAE.
Okay, look, that's the point at which we're going to have to finish on. Thank you very much, everybody, for contributing this evening, and thanks for up to our speakers again. Just two very quick things to finish on. This is the second of our conversations. Third one we've got penciled in for February. Code name design at the moment, we're still sort of developing the location, the contributors and so forth. And of course, now you're here, you'll be on our mailing list and you'll hear all about that in due course. How do we pick up what we've talked about this evening? Well, as I said before, we'll put the video of tonight's event on our website in case anybody enjoyed it so much they want to relive it all again. But, my job will be to try and pick up some of the threads and put that in a maybe as provocative sort of blog format as I can, which will give anybody who wants to the chance to contribute that. So maybe the debate can continue online, but it definitely can continue for at least the next half an hour in Frank Whittle room, which is across the hallway from this room. So please join us for a little while for a drink. So thank you very much.